Hi, and welcome to this look at some applied calorimetry questions. They're applied because it's not the enthalpy of combustion they're asking for this time around. Normally it is, and these ones they're asking for something else within the calculation, but they give you the enthalpy of combustion, so you've got to do a bit of rearranging and working backwards. So there's three examples, and I'll go through the first couple and leave you to have a quick think about the third one. Okay, so first thing to do is to get my laser pointer so I can highlight things I need to. So firstly, let's have a quick look at MC delta T. So Q equals MC delta T is obviously the equation we're talking about, where the change in energy is joules, that's Q. M stands for the mass of water heated by the reaction. The specific heat capacity of the water is fixed at 4.18 joules per Kelvin per gram for our exam board, LCR, and the change in temperature is in Kelvin, but it can also be expressed as degrees C. And then finally, you need to take your Q value and divide it by the moles of substance reacted, whether the reactions of neutralization, or whether it's just a straightforward reaction between two things, or whether it's a combustion. It doesn't really matter. The important thing is that moles reacted needs to be worked out using mass over MR normally. So let's have a look at our examples. I'll do the first two parts, and like I said, you can have a think about the third. So let's begin with the top one. I've highlighted delta T because they want us to work out the initial temperature of the water. So to do that, you need to think about what delta T represents. It represents a change in temperature. They said they recorded the final temperature as 81 degrees C. So 81 take away the initial temperature is going to be the change in temperature. So that's what we're trying to isolate. Let's set this value here. So to do that, we've got to find Q. Now the problem is we don't have the temperature change to do that. So therefore we've got to come at it a different way. You need to use the idea that the delta CH value for your ethanol is minus Q over the number of moles of ethanol that's burnt. So to work out the number of moles of ethanol that's burnt, you can obviously insert in minus 1367 in because they just tell you what that is. Normally this is the value you'd be working out in a more straightforward version. But this time round you have to work out this. So they provide this for you. So to work out the number of moles of C2H5OH, you go back to the mass of ethanol, and that's going to be 0.446 grams over 46 grams per mole minus 1. And it gives you this number here. I'll bring down the calculator value to keep it nice and straightforward, so we don't lose any accuracy as we go through the stages of the calculation. So Q is going to be minus 1367 times that value. Rearranging, so Q is the object, or subject rather, and that gives you minus 13.25395652. It's in kilojoules, but if you remember from the previous screen, it said that it's got to be in joules, so you multiply that out by 1000. So now what you do is delta T, to get that, it's Q over MC, and that gives you minus 12.68321198, and then finally you can work out the initial temperature by rearrangement, and it gives you 68.32. Checking the mark scheme, firstly you work out the number of moles of C2H5OH. You work out Q in joules using delta H provided plus the number of moles of C2H5OH you just worked out. Then you rearrange to make delta T the subject before finally working out the initial temperature. And it's written here to 3 sig 68.3. So let's do the next one very quickly. I'm going to speed up a little bit here. So M is going to be the thing that we want to work out because that's connected to the volume of water. 1 gram of water is the same as 1 centimeter cubed. So again, you need to find Q, the same way we did before. Insert the minus 1367, and this time we put in 1.23 grams as the mass. That gives us a different number of moles, which therefore gives us a different value for Q. So this time M is Q over C delta T. So you put the numbers in and you get 372 centimeters cubed as your volume. Quick check of the mark scheme there. Firstly, working out the number of moles of alcohol, and then you work out Q in joules, the same way as we did before. You rearrange this time to make M the subject, plug the numbers in, and you get volume as standard form and 3 sig figs. Thanks for listening. Until next time, see you soon.